All right, everybody, welcome. Now we get into the reality of what it really is. VLSM. You're not going to have the same number of IP addresses per segment. You're not going to have that. We just came from classical subnetting. You were able to see how to do it, and you have the same number of subnets per segment, per network, per whatever, per floor. Okay? But again, that could be a waste of IP addresses. And I said, you can go to hotels and what have you, and you'll be able to see that that's probably what they do. They use a Class C address, and every floor is, the lobby is 0, and the first floor is 1, and 2, and 3, and 4, and so forth until they reach 255 floors. I don't know. All right. But in reality, when we're going across whatever networks or we have different nodes within the company, VLSM, variable length subnet masking, is the way to go. Now, remember, the reason VLSM came about was because of the demise, the quick death of IPv4, because the public addresses were really being allocated improperly, because nobody knew that the internet was going to exponentially explode and they were going to be wasted that quickly. So VLSM was made for that purpose. All right, so what I have here behind me, and again, we're going to go inside the lab and I'll show you an example, something similar to this. This will be for you, obviously, when we upload it, for you to go ahead and work on. But it's like a corporate headquarters that has 350 nodes, then 200, 150, 300, and it keeps going. Okay. All right, you see you have factories that have 35, 50, 45, and so forth. So you're given a particular IP address, right, or network, I should say, with a default mask, and then you need to start doing it from there. Now, VLSM, which I will explain again in the lab, it does use IP subnet 0, so you will use the 0 network. All right, so all networks are good to go. All right, you will start from the highest number of nodes, and then when you finish the first one, you always want to look at the next available IP address and then go from there. All right. So now the concept that you're about to learn is not something that you're going to have to do for your certification, but that you have to understand what VLSM is. All right. So I think you'll get enough practice in this particular section to get a good grasp on VLSM. All right. I'll see you in the next. All right, this is the problem that we're going to work with inside the lab. As you can see, it's already done, but we're going to get inside the lab and we're going to work it together step by step. I'll see you there. All right, here we are inside our VLSM, right? We're going to break it down so you can see it better. I'm not in your way. This is why I decided to do the desktop recording like I told you before. Now, we were given a 172.16.0.0. As you can see, I took the last 2 octets and I put them in there, binary, or all zeros are all off, right? We had a CIDR 16 to start off with. So we're going to go ahead and have all those like this. Now, when summarizing, as I said previously, we start from the highest number and work our way down, all right? So, but we start with the number 172.16.0.0. We are using the 0 network, so we will start with the 0 network. Okay, so we need 350 hosts. Now we know we count from right to left and we get up to here, that's 256. One more will give us 512. So our first line is going to be right there. That's going to give us 512 hosts, which is more than enough that we need. So we come here for our broadcast, and let's just write it, because we're going to write the range as well. So we got 172.16, right? Dot what? Dot 1 dot 255. How did I get those numbers? Well, I took this bit value, which is this bit value, all right, and I added it to the third octet, which is 1, and then the last one, we all added up, is 255, is 255. So that will be your range. Now, I know I have it here, but the only reason is because then I have to bring it back in. All right, so what is our first available IP address? 172.16.0.1 through 172.16.1.254. And then, of course, we have our broadcast. And let's move this a little bit further just to make it make sense. Not everything's jumbled up together. A little bit more. There we go. Okay. And then our CIDR, or our mask, right, insider notation, will be a /23. Okay, so we got the range, we got the subnet, and we started from 0, and then we got our broadcast with our new mask. You give that out to the network administrator, and then he can resubnet it or do whatever he needs to do to work within his infrastructure, his network, his side of the network, whatever the case may be. Now, here's the important thing. What is the next available IP address? Well, if you look at the broadcast, you see it says 1.255. So that flips over. This goes to 2. So our next network is 172.16.2.0. Okay, that's our next starting point. Now, can we move the line? No, because if we move the line, we will not have 300 hosts available. So the line stays where it's at. Okay, so let's find our broadcast address. 172.16. Dot what? Well, you still have this bit value right here, which is 1. And 1 plus 2 is 3. And then the last octet is 255. This is your broadcast address. So what is your first available 172.16.2.1 through 172.16.3.254? And let's bring the broadcast back up here. All right, and then we have the same CIDR or same mask because we did not change, and I can't find it. Oh, here it is. We did not change. We did not move it. We did not move it at all. Okay, so now we go again. What is our next available IP address? Well, 3.255. We go to 4. Okay, so 172.16.4.0. Okay, and then we say, okay, now this is our next available. We need 200. Can we move the line? Well, we sure can. We can move it to right here, right? Because here will give us 256 minus 2 is 254. We have only need for 200. So more than enough. So now everything in the third octet stays the same. What changes is in the last octet. All right. So what is our broadcast? Our broadcast is 172.16.4. All the zeros, 255. That is the broadcast. All right. What is the host range? 172, not 5. 172.16.4.1 through 172.16.4.254. And again, let's bring this back in here. But we did change the line, so it's not going to be the same CIDR. This is going to be a CIDR 24, because this is where our line is at now. All right, the first 3 octets are already being used up, so we can no longer mess around with it. Now we're in our 4th octet. And again, we ask ourselves, what is the next available IP address? 4.255. Okay, so we go to 5. That's the next available. 172.16.5.0. Okay, so we need 150 addresses. Well, we got 256 there. Can we go any lower? 2, 4, 8, 16, 32, 64, 128. No, we can't. The line needs to stay there or else we will not have enough addresses. And let me fix this right here. I think I added one extra one. I don't want to confuse nobody. Okay, so we need to find the broadcast for this one. Pretty much the same scenario, 172.16.5.255. All right, that is our broadcast address. So what is our first available? 172.16.5.1 through 172.16.5.254. And then we bring in our broadcast in here. And we did not move the line. Therefore, the subnet mask stays the same. Stays the same. All right, next available, 6.0, right? Because we looked at that 5.255. We said, well, the next one is 6, 172.16.6.0. Now we need only 50. So it looks like we may have to move the line. So 2, 4, 8, 16, 32, 64. Okay, so our new line is right there. Perfect. Okay, so now we're within the fourth octet. So now we go 172.16 dot what? Well, dot 6, first of all, but no longer the broadcast is going to be 255 because we're now inside, right? So if you add these bit values right here, we come up with 63. How did I do that so quickly? It's just one less your increment, which is 64 right here. So 63 is your broadcast. So let's move it over to the side a little bit. And let's go ahead and put in our first available IP address, which is 172.16.6.1. But now we can only go up to 172.16.6.62. Delete, delete. And then our new mask would be a 26. Okay, a 26. And then the last one, 45. Can we really move the line? Not really, because 2, 4, 8, 16, 32, 64. If we move the line over here, we're only going to have 30 actual IP addresses. So the line needs to stay where it's at. So we have next available IP address, 172.16.6.64. That's our next available IP address. What will be the broadcast? 172.16.6. What? 63, right? Because we're adding all these bit values right here, which means you're adding all these guys right there. That's 63. 63 and 64, that's 127. Okay? So we're going to move this a little bit over to the side. All right, let's put in our first available IP address, 172.16.6.65 through 172.16.6.126. And let's move this over this way so everything lines up nice and neat. We did not move the line, therefore it will still be a /26. And that's what VLSM is all about. First of all, starting with the highest number of nodes, going to the lowest, and then starting with the zero network, and then using the next available IP address. Remember, the whole point of it is to use the least amount of IP addresses. But we'll talk about it later. I'll see you outside the lab. All right, that wasn't so bad. Wasn't so bad. We got the answers. All right, we got the answers. You saw how we came about by drawing our lines. Some of them maintained their mask because we had we couldn't change. I'm sorry, I got stuck there. We couldn't change the line because then we wouldn't have enough hosts. All right, we didn't have enough hosts, but it changed, from a 23, 24 to a 26. And again, using from the highest number, which was 350, to the lowest number, which was 45. Always remembering, hey, what's my next available IP address? Okay, if you keep that in mind, you should have no issues. But again, this is something that you're not going to have to do in the certification. This is to understand what VLSM is, that we're able to adjust the subnet mask no matter what class of address we're using, all right? So we can go ahead and make it more efficient in our particular network. All right, I'll see you in the next one. All right, how do we create a VLSM network? It's not a big deal. It's design though, design. This is the lab that we're going to be working with once we go inside. That way, labs is not going to be in your way. But you're going to see that we have a 28, a 29, and then even a class A up here, which it says, hey, there's the VLSM network, but it's discontinuous. But as soon as we get inside, you'll understand why. I'll see you inside the lab. All right, welcome back to the lab. Now we said creating a VLSM network. Basically what we're doing here, we have different subnet masks per network. As you can see, you see a CIDR 28 for one network, you see a CIDR 30 for another, and a CIDR 29. What I want you to pay close attention to is a couple things. First thing is you see this 192.168.116. If we were to do the same concepts that we just did in our previous exercise, the next network would be 32, right? 16, 32. That's why you have 32 here. But here we don't have a need for 14 hosts. We only have a need for 16 hosts. Therefore, the mask is 29. There's where the VLSM comes in. And up here between the routers, we only need 2 IP addresses, but I decided to use a class A. And I usually do this in labs because it's a visualization. So you know that, hey, class A is between routers and it's going to be point to point. We only need 2 IP addresses, but we have a different subnet mask. This is what's called a discontiguous network. Our routing protocols support this, so it's not an issue. And our routing protocols support VLSM as well, so we don't have an issue. So this is what I mean about creating a discontiguous network. All right? Okay, I'll see you outside the lab. All right, that wasn't so bad. We just did this really off the top of my head, but one thing that I told you to pay attention to that uses the concept that we just previously learned. You see that this is a 192.168.1.16 with a CIDR 28, which means it increments by 16. So the next network would be 32. And I said it while we were in there. So we start with 32, but this time we only need 6 hosts. Therefore, the mask changed to 29. And obviously, in a point-to-point network, we need a CIDR 30. Why? Because there's only 2 IP addresses. So this is your VLSM. Why is this discontiguous? Because we're using different classes. We didn't stay in the same class of address. But that's okay. Our routing protocols, as I said, will support that. So it's as easy as that. But again, extremely small network. If you're designing an enterprise network, a very large network, definitely a team of people is what you'll need in order to collaborate and make sure that we don't have overlapping addresses and everything goes just fine. All right? So this is it. I'll see you in the next one. All right, welcome to the summary of this section, which was VLSM. Now we got an introduction to VLSM, the reason why we use VLSM. Remember, because they said, we're running out of IPv4 addresses. We weren't supposed to give out that many addresses. Let's go ahead and do VLSM, right? So, and when VLSM, it really pertains to public IP addresses. We use private as examples. Even though you can do VLSM within your private network, I'm not saying you cannot. But it basically was done because of public IP addresses were running out. Now, we did do Vlsm, forgot the M there, breaking down VLSM, and we broke it down step by step. We went inside the lab, and we saw how we got our different networks with their range, our broadcast, and our different types of masks, right? Highest number of hosts to lowest number of hosts, right? Starting from the 0 network, because VLSM does use the 0 network, alrighty? And then look, okay, this is my last IP address, which is your broadcast ID, and then we go from there. Don't forget that. And then creating a network, and that was very simple. It was 2 routers, 2 PCs, and you saw that we had a CIDR 28, and then we had a CIDR 29. The CIDR 28, we incremented by 16. The first network was 32. The next one the first one was 32. The next one should have been 48. But we didn't. And then we changed it to a 29 because it was the number of hosts. So it falls into the concept. If you look at the number of hosts that you need, you'll know what subnet mask will follow. Okay? And then, of course, on the top, we had a 10 network, or class A, with a CIDR 30 because there's a point-to-point. We only need 2 IP addresses, making it a discontiguous network. But like I said before, our routing protocols today, they support discontiguous network, so it's not a big deal. So there you go. That's VLSM in a nutshell. See you in the next one.